I am on page 34 in the textbook, and if you've been bored up to this point, this may be a little bit more of a challenge. Hopefully, you haven't been bored, and this will just be a progression in what we're studying. But I do want to put a page in the notebook for this one, and I'm going to go ahead and label it. We're just going to call it solving two-step problems. Now, we've been solving word problems, but they've been one-step problems. Two-step problems are just by design more difficult. And they're story problems, so that makes them even more difficult. You have to read the story and figure out what you're supposed to do. I personally like story problems because as long as I know a story, I can understand what they're asking me much better. But some people struggle with these, so I'll try my best to help you learn some strategies that will help you do better. So let's take a look here. When you solve a two-step word problem, you may have to add and subtract. Those are the two steps. You can use bar models or equations to solve two-step problems. The first thing I want to do is copy this problem into my notes. So let me just take a quick picture, and we will go to our notes and write this one down. And remember, you can pause the video if I'm going too fast, or you can speed it up if I'm not going fast enough. All right, Rita went on a trip. So they're setting up the story for me by telling me that Rita went on a trip. End of sentence. She spent $359 on a hotel room and meals. End of sentence. She spent $29 on lunches and $112 on dinners. End of sentence. How much? So we're looking for money. How much did Rita spend? That's money I'm looking for. On the hotel room. This question could be on the high school equivalency test because it's more than a basic question. All right, so let's break it down using the strategies you've learned for word problems. Highlight the question. How much did Rita spend on the hotel room? So the hotel room is the missing piece of the puzzle. So let's look at the other pieces. We know that she spent a total of $359. That was on the hotel room and the meals. We know that she spent $29 on lunches and $112 on dinners. And we need to know that third piece of the puzzle. So they want us to use a bar model, and I think that's a good strategy here. So draw yourself a bar. It doesn't have to be perfect, it's just a sketch. And this bar represents the total amount spent. And we know that that was $359 in total. And we know that she had 3 expenses. She had lunch, dinner, and the room. So lunch was a little part. Lunch was $29, or lunches. Dinner was quite a bit more. That was $112. And this unknown part is the hotel room. So this model just helps me to see what I need to do here. And I'm going to go ahead and show you the advanced way to set this up. Okay? Would you agree with me? Let me think how I want to word this. Let's set it up this way. The $359 covered lunch and dinner. Those are her meals. Plus, I'm about to mess up here. Let me think. I'm not about to mess up. I just don't want to get you confused. Let's leave that off. Lunch and dinner and the hotel room. So what this diagram is showing me is that I'm going to take my total and I'm going to put that out here. And then this is sort of like the box. It's the bar model that I've drawn. Lunch and dinner and hotel room. So what is inside that bar model, I'm going to put in parentheses in my problem. So I would have 359 minus lunch plus dinner plus the hotel room. So now let's go ahead and combine these two numbers. We can do that. So I'm going to come over to the side and do it because it does not say we can use a calculator. So 112 plus 29 is 141. So I have 359 minus 141. Let's keep that for a minute. Plus the hotel room. So what we can say right here is that the 359 minus the 141 is going to equal the hotel room. And now we need to do that problem. So we have 359 minus 141 is going to be an 8, a 1, and a 2. So $218 is the price of the hotel room. This is an algebra problem, and I have shown you the advanced way to solve it. We're setting up the algebra that you're going to need in the very near future. But I realize that this is not an easy problem. This takes a lot of thinking. It takes a lot of math. But most of all, it takes a lot of organization to keep this problem straight. And highlighters help. Let me highlight these so you can keep track of those. Set your problem up in a way that it makes sense to you. That's the best advice I can give you. Let's go ahead and put a line here, and we'll add another example down here. Possibly two more. We'll see. All right. And we see that they agree that Rita spent $218 on the hotel room. All right, let me take a picture of this one. And we'll add it to our notes, and then we'll come back here. So I'm going to copy this problem in, and then I'll delete this. The pancake house. Served 212 breakfasts. Some lunches. So that lunch number is unknown. And 150 dinners. I could eat pancakes for dinner. End of sentence. A total of 549 meals were served. End of sentence. How many meals were lunches? Question mark. And then they want us to pick which bar model best shows the problem, and we'll do that. But first I want to solve the problem because it's a good question. All right, so the question itself is how many meals were lunches? So they want to know the number of lunches. So let's take a look at what we know. We know that there were 212 breakfasts, 150 dinners, and that a total of 549 meals were served. So let's draw our bar model. Just make yourself a bar. Doesn't have to be fancy. And let's put our total up here. We know that our total was 549 meals. And then we're going to break down the types of meals inside the model. So I'm just going to split it evenly, kind of. It looks like the breakfast, there were a lot of people who got breakfast. And that makes sense because that's when I think of eating pancakes. It doesn't matter if your bars are not marked off equally or what. Just get the gist of the problem. And then we know that there were 150 dinners. So these are those green pieces of my problem. We know that one and we know that one. We do not know the number of lunches. That's what we want to know. How many lunches? So what we would do, we would say the total. Let me think how to front. I'm just going to use the same method as I did before. In my parentheses, I'm going to put my breakfasts and my lunches and my dinners. And we know that our total was how many? 549. We know that we had 212 breakfasts and 150 dinners and some lunches. We're working on that. So we know that our total was here. We know that our breakfasts and our dinners, together, we can add those. So let's go ahead and do that over here. Let me leave myself some room. So we have 212 plus 150. That's 362 breakfasts and dinners. So I'm left with this problem. So if I take my total, 549, minus 362, that's going to tell me how many lunches there are. So I'm taking that 362 away from the total that we've been tracking all along. So I'll have to do that over here. 549 minus 362 is going to be 7. Have to borrow here. 14 minus 6 is 8. And 4 minus 3 is 1. So that leaves me with 187 lunches. And that was the missing number. Now they're going to ask me which model is the best. So let me take a picture of this. It's trying. Well, it's still trying. Okay, there we go. So when I come back here, let me paste my picture. All right, so which one of their pictures most closely matches mine? Ours. Well, it's not that one because we know the total. That one looks good. There's 549. I like that one. This one, the total's not right. And this one, the total's not right. So the one that matches is B, as in boy. They have gone ahead and combined their breakfasts and dinners like we did to get the 262. But, I'm sorry, 362. It's the total you want to look at. That 549 is correct. And then the 362 was the combination of breakfast and dinner. So the answer here is B as in boy. Hint. When you read a word problem, think about what information is given and what piece of information is missing. On page 35, let's practice. Which problem does the bar model show? Well, I've learned that this number represents a total. So I'm going to keep that in the back of my mind. And it looks like in this particular problem, we're comparing types of milk. So we have 129 whole milk, 227 skim milk or non-fat milk, and the unknown is the amount of 2% milk. So I have no idea what this story is, but let's look at our choices. Tom delivered 566 gallons of milk. That would be the total. 129 gallons were whole milk. 437 gallons were 2% milk, and the rest were non-fat. How many gallons of milk were non-fat? Well, this is not the answer for two reasons. First of all, the total's wrong. Our total is 437. The other problem is that the unknown is not the non-fat. We know the amount of non-fat. The unknown is the amount of 2%. So this is not the choice I'm looking for. B. Tom delivered 437 gallons of milk. I like that because that matches my total. 129 gallons were whole milk. That fits. 227 gallons were non-fat. That fits. How many gallons of 2% did he deliver? That fits. That's it. That's the answer. But let's look at the others. Tom delivered 129 gallons of milk. 129 gallons of non-fat milk. That's correct. 227 gallons of 2% milk. We don't know the gallons of 2%, so that one is not correct. Tom delivered 227 gallons of milk. I can stop right there because he delivered 437 gallons of milk. The answer you want is B as in boy. And we didn't have to do any math. That one is just about reading. Number 2. A bakery had 645 pounds of sugar. On Monday, it used 239 pounds of sugar. On Tuesday, it used 30 pounds more than it did on Monday. How much sugar was left? This is a doozy. So I'm going to copy this and take it to some scrap paper. I cannot possibly squeeze that in here. So let me see if I can add a piece of scrap paper. And I can. So I'm going to paste my problem. You can just look at yours in the book and work with your scrap paper. So I'm going to make a model because that's the strategy they want us to use. So let's draw a bar model there. And I'm going to put in my total. Actually, I'm going to do a little bit of highlighting first. The question: how much sugar was left? And the word left tells me that I need to subtract. All right, let's find the information that we know. They had 645 pounds of sugar. So that's going to be a total. Then they tell me that on Monday, the bakery used 239 pounds of sugar. So let's make a mark here and call that 239 pounds on Monday. On Tuesday, they used 239 pounds plus 30. Because right there it tells me on Tuesday, they used 30 pounds more than they did on Monday. So you have to take Monday's amount and add 30 to that to get Tuesday. And then you can find out how much was left over. So if you follow the highlighter, there's the Monday and Tuesday amount. Here's your total, and then here's what we're looking for. So I'm going to set this one up as 645 minus Monday plus Tuesday, and that is going to give us the leftover amount. So if you follow the highlighter, you've got your total minus what they used up, and that will give you the amount that's left. So we need to do this amount first. So I'm going to come up here and say 239 plus 239 plus 30. That's 18, carry 1. 3, 6, 9 plus 1 is 10. 4 plus 1 is 5. So that's 508. This is a good high school equivalency question. You're doing algebra. So if it feels difficult, it is. So I need to do the 645 minus the 508. And that will give us a situation where we have to borrow. 15 minus 8 is 7. 3 minus 0 is 3. And 6 minus 5 is 1. So 137 pounds is what we had left. So what we did, follow the highlighter, total minus this number gives us this number. And that should be the answer we're looking for. Sorry, I went to the wrong page. 137 pounds left. Number 3, I think I'm going to do the same thing. Just going to take the problem over to my scrap paper because I need quite a bit of room here. Actually, we might not have to do this. Let's try this one right here. 400 housing units were sold in June. Some of the units were condos. 205 one-story houses were sold, and 120 two-story houses were sold. How many condos were sold in June? Which equation matches the problem? Since we don't have to solve it, I'm going to go ahead and draw it right here. I do have room to do that. So let's take the word problem step by step. The question is how many condos were sold in June? We know the total is 400 housing units were sold in June. So let's go ahead and put this here. I'm just going to call it 400 units. And we know that we had 3 different kinds. We know that we had condominiums or condos. That's the unknown. And we know that we had 205 one-story houses and 120 two-story houses. So there are 3 different variables in this problem. Goodness gracious. We know that we had 205 one-story houses. We know that we have 120 two-story houses. And we know that the unknown is the condos. So let me follow the highlighter for you. We know these. We know the total. But we do not know the number of condos. I can tell you, however, that 205 plus 120 plus the unknown adds up to 400. Because if I follow my thinking, there's the total. These are the 2 we know plus the 1 we don't know. So I know that my answer has to equal 400. That would eliminate A, and that would eliminate D. So we could choose B or C, and I'm going to eliminate B because those are all subtraction. I want addition. I want this one right here. So my answer is going to be C as in Charlie. 205 plus 120 plus the question mark is 400. Number 4. Many people watched a parade. There were 425 children. There were 176 adults. There were 57 fewer teenagers than adults. How many people watched the parade? This is an algebra question if I've ever seen it. So let's take this over to scrap paper and see what we can do with it. So I'm going to paste my problem and I'm going to highlight it. Many people watched a parade. That's your total, and we don't know that number. So when I draw my model, we don't know. At least not yet. We don't know the number in total. So this number is the unknown. We do not know the total. But they gave us the tools to find the total. We know that we have kids. We know that we have teenagers. And we know that we have adults. Let me go ahead and follow form. How many people watched the parade? That's the question. We're looking for the total. We know that there were 425 children, 176 adults, and 57 fewer teenagers than adults. So let's put these pieces into the puzzle and see what we get. 425 children, 176 adults, and the teenagers, we have to do a little math. We have to take the adults and subtract the 57, because there were 57 fewer teens than adults. But guys, we can do that. We can absolutely do that problem right there. I'm going to do 176 minus 57. So I do need to borrow. 16 take away 7 is 9. 6 take away 5 is 1. And 1 comes down. So there are 119 teenagers. Okay. So we don't need that. We've actually found the number. Now to get the total, what would you do? I would take the children, the adults, and the teenagers and add them to get the total. 6 and 5 is 11, plus 9 is 20. 4 and 7 make 11. One more makes 12. 4, 5, 6, 7. So the total is 720 people. So we have found the answer that goes here. Do you see how this model helps us stay organized? It helps us find out what we need to do and what we already know. So the answer I want is 720. I keep going back to the notebook. How about this one? D 720. Okay, this one I do have to solve, so I'm going to go ahead and clip it and take it over to my scrap paper. When the problems get this long, you probably are going to have to do them on scrap paper. They just don't give us enough room on the page. And you can't write in the book anyway, I think. So, all right, let's read this one. A movie theater had 355 tickets available for its noon showtime. It sold 180 tickets for the drama and 169 tickets for the comedy. How many tickets were unsold? So I know the total that were available. I know that 180 of them went for drama and 169 went to comedy. And so now I can draw my bar. I do know the total. And I know that those are broken into 3 groups. We have 180 for drama. We have 169 for comedy. And then we have an amount that were unsold. That is the unknown. That's the thing we're looking for right there. We know the total, we know the drama, and we know the comedy. So here's what we know. That the total minus the drama and the comedy will give us the tickets that did not sell. Okay, so the first thing you and I need to do is this addition problem right there. We need to find out what that amount is. So 180 plus 169 is 914, carry 1, 349. So that's our drama and our comedy together. And then we're going to take the total that we were given and we're going to subtract to find the unsold. So 355 minus 349. Have to borrow here, so that would be a 4 and a 15. And I'll tell you what, let me raise that just a little bit so we don't get it mixed up. 15 take away 9 is 6. 4 take away 4 is 0. And 3 take away 3 is 0. So there were 6 tickets that did not sell. That's pretty good to have only 6 unsold. And that should be our answer. And there it is. That's always nice when you can look down here and see your answer. 6 tickets did not sell. That's answer A. All right, numbers 6 and 7 refer to the bar model. So I don't have to draw a model, it's already drawn for me. I will not clip this one, we'll just work it right here. But let's break it down. We know that there were a total of 546 cupcakes sold, that 105 were lemon, 263 were chocolate, and the vanilla were unknown at this point. This is my kind of problem. How many cupcakes sold were either chocolate or lemon? So the question is asking about chocolate or lemon. So we know that there were 263 chocolate and 105 lemon. And we want to combine those to see how many of our cupcakes fit this description. So there's 368 of them fit this description. So I like C as in cupcake. So once we know that, we can find out how many vanilla cupcakes were sold. Because we know that there were 546 cupcakes total, and we're going to minus the 368 that are chocolate and lemon, and that will give us the number of vanilla. So using the algorithm, 546 minus 368 is going to be have to borrow twice. 178 of those cupcakes were vanilla because those are the chocolate lemon. This is our total, and this was our unknown. So I like the answer B, as in bakery. These are not easy problems. They're definitely high school equivalency type problems. They take the skills you've learned and they make you use several of those skills in one question. And that is what we call a two-step problem or a multi-step problem. And these are the kind of questions you can expect on a math test, just about any math test you do. We will practice more of these in the workbook in just a minute or in the next video.